Hi, this is Mr. Ward, and I'm going to talk about fractional exponents, which is the topic of exponential functions level 3, fractional exponents and radicals, which are fractional exponents are a way of expressing that I think actually makes a little more sense than radicals. Uh, but I'll be connecting the two and seeing how they relate to each other. So you know that fractions are a way of breaking up things. It comes from the word to fracture. It's the same root. So fractions are about breaking things up into pieces. If I'm breaking up my pie into 12 pieces, I am going to break it up into 12 equal pieces, and they would be called twelfths. And if I ate 3 of those pieces of the pie, then I have eaten 3/12 of the pie. The denominator tells you how many equal pieces there are, and the numerator tells you how many of those pieces are being considered. So the numerator is kind of a multiplier, and the denominator is a kind of divider, the dividenator. So how does that apply to exponents? Well, an exponent, if it's a positive whole number type exponent, then it tells us how many times we're using something as a factor. If it's a negative number, it tells us how many times we're using the base as a divisor. And if it's 0, it tells us we're not using the base at all as a factor, and all we're going to leave behind is a 1. When it's a fraction, though, we're considering how many equal pieces are we going to break the base into. But remember, exponents are timesy way of thinking. So we're not going to take a number and split it in half like if we took 9 and split it in half in an addition sort of way, we'd split it into 4.5 and 4.5. In a timesy sort of way, we're going to break 9 into two equal factors of 3. So in a timesy way, half of 9 is 3. So 9 to the 1/2 power equals 3, because to the 1/2 power, we're taking 1/2 of the equal factors of 9. 27 to the 1/3 power would mean we're taking one of the 3 equal factors of 27. So I'm going to go to Desmos notes so I can sort of capture some of these ideas. Okay. So if I'm saying 27 to the 1/3 power, that equals 3. And why does that equal 3? Well, because if we break 27 into 3 equal factors, they are all 3s. And so we get 27. Okay. And then I could say 64 to the 1/6 power, and I would get 2. And why would that be so? Well, because 64, if broken up in a timesy sort of way into 6 equal pieces, those 6 equal pieces being factors, they would be 2 times 2 times 2 times 2 times 2 times 2. And there are 6 factors of 2. And since I'm asking for the 1/6 power, I take one of them. Okay, well, what would it mean if instead I talked about the 5/6 power? Well, if it was the 5/6 power, I'm not going to take one of those twos. I'm going to take 5 of those twos. Okay, so think about this for just a second. What would 5 twos be in a timesy sort of way? In the addition way of thinking, it would be 10. But this is not 2 plus 2 plus 2 plus 2 plus 2. This is 2 times 2 plus 2. 2 times 2 times 2 times 2 times 2. Oops, that was not what I thought it was. I'll try that again. So I'm going to copy this. And I'm going to put 5 factors of 2, and I get 32. And let's see what it says up here. So this is the 1/6 power. What if I'm asking for the 5/6 power? Well, it's 32, because I'm breaking 64 into 6 equal factors, and then I'm going to take 5 of them. Okay, the numerator tells me how many I'm taking. The denominator tells me how many I'm breaking it into. They all have to be equal, and they are factors. And factors will do what factors do. They multiply. Okay, so that's one piece of this that we need to consider. Another piece is what if um, what if this number, this denominator, the number that I'm going to be breaking this into isn't neat and tidy. Let's say I said 3 to the 1/2 power. Well, I get this number. Well, this number is also known as the square root of 3. So there's quite a few situations where you're just going to end up with something messy. So it'll be useful to know the other notation of this. So I'm going to say square root. If I type in square root, let me do that again. If I type in SQR and then I hit a T, it gives me a square root symbol. The square root is the same as the 1/2 power. So if I put a 3 in there, I get this same thing. This thing actually does not show us the whole number. This is an irrational number, which means it goes on forever. It does not settle into a repeating pattern, and it cannot be expressed as a ratio of two numbers, which means it is not a rational number because it can't be a ratio. It is an irrational number. There's an infinite number of them, and the square root of 3 is one of them. So sometimes you'll have fractional exponents on things that will not be neat and tidy. Most of this level is going to be focused on the ones that are neat and tidy. So, and when we start dealing with ones that aren't, we'd probably use a calculator or some sort of table of values to help us out. Because I'm not going to expect you until you've had some calculus under your belt to be able to come up with what the square root of 3 is. Once you've had some calculus, there's some tools. There's a thing called the Newton-Raphson Method that allows you to actually calculate to many, many, many decimals what a square root of an irrational, a square root that leads to an irrational number is. Okay, so let's actually look at the components of this. I'm going to remove these irrational numbers, and I'm going to focus on the rational ones. So let's think about this 64. So if I were to go ahead and I'm going to use a root, okay, I can also grab it there. And it's not, let me see if I can make this work. One moment. Okay, so if I just want a square root, I can type SQRT. But what if I need a root that's something else? Well, I'm going to need to go here to this button. I have to drop down and go to functions in Desmos, and then it opens up all this stuff. There's all these options, and I'm going to drag down all the way down here to this little notation. That n is going to be the kind of root I'm going to get. So I'm going to grab that, and I didn't want it there, but I can now copy it down to here. Okay, and I'll drop this. I don't need that anymore. And so what we put here, this is going to be the number that we would put in the denominator. So if I put a 64 here, and I put 6 here, this is 2. This is the same as saying 64 to the 1/6 power. It's 2. So I'll drag that down so we're all together. So 64 to the 1/6 power and the sixth root of 64 are saying the same thing. This is another way of saying I'm taking 64 and breaking it up into 6 equal factors. You might notice that the square root symbol looks like a fancy long division symbol, and I think that's probably for good reason because rooting is a kind of special division. We're dividing 64 by something that will allow us to divide it 6 times by that same thing. Okay, so that's 64 to the 1/6 power. Let's say we had 64 to the 5/6. Remember, we got 32. Well, I can put that 5 actually as an exponent of this whole expression. I can put it outside and I get 32. These are the same notation. This 5 is the exponent in a way, it's the power that I'm raising it to, and the 6 is the root that I am taking it down to. Now, that 5 I could also put inside, put it there. And that gets me 32 as well. So I can put the 5 inside or outside. Either way works. And so this is just another notation. I'm going to go here into the fractional exponents section. And there's a little bit of notation here that shows you what I'm talking about. So if I have some number, we'll call it x, that's raised to the 1 over n power, what I'm doing is I'm breaking x into n equal factors. And that's the same thing as saying the nth root of x. So if n was 7, I'd put a 7 here, and I'd be getting the 7th root of x. So 128 is made of 7 factors of 2. And so the 7th root of x was 128. The 7th root of 128 would be 2. Now, that numerator could actually be something other than 1. So there's this other notation, x to the m over n. The m is like a multiplier in a way, and it's the exponent that you would put outside this structure that's called a radical. So if I had 128 to the 4/7 power, 128 being made of 7 factors of 2, I would take 4 of them. And so these are other notations. So you'll want to be able to interchange between these kinds of notations. I'm going to say one last thing. What if my exponent, my fractional exponent, actually I'm going to stop. I'll do that in a separate video.